Everyone, and today we'll be seeing one of the problem from LeetCode. It says divide an array into subarray with minimum cost, and that is problem number 1. As it is an easy problem, we'll not spend much time upon the question. The question is pretty simple. It goes like we are provided with array nums with length n, and the cost of this array is determined by the first element out of this array. So if you are having an array such as this, the cost of this array is 1, the cost of this array is 3, because the first elements are 1 and 3 respectively. Now we need to divide this array into 3 disjoint contiguous subarrays, and we need to return the minimum possible sum of cost of these arrays. So if you have an array like this, the minimum is 6, because if you are dividing it in such a way that it goes like 1 with one element, 2 with another element, and 3, 1, 2 with another element. So you have cost as 1 plus 2 plus 3, which is 6 here. And this is pretty simple. Each element takes its own subarray. Here it is like 10 is individual. 10, 3 is 1 is individual, and this one is individual. Now with that thing in our mind, let me take this example itself. The problem is pretty simple, and that we need to minimize it, and we need to take 3 subarrays out of it. And we had an example like this, so I'll just take this example. And this is with this example 0. Okay, my bad, 0. What is happening here? Okay, 0, then we have 1. These are nothing but indices, 2 and 3. So this is index, this is value. Okay, my bad. Anyways, so zooming in a bit more, so this is index, this is value. Now with this thing, what we can understand is we need to divide it by 3 parts. So for sure, a part is from this point to somewhere here, and from here to somewhere here, and then to the end. So that means no matter what, I have to take the first element. There is no other choice, but I have choice for rest of the 2. So my subarray would include this first element, but I have choice to, shall I consider second subarray as this, or from here, or from here. Anyways, so what should I do? I want the minimum, right? Minimum, and I know minimum I need to find from 1 to n, and not once, but I have to find 2 minimums. Now the problem is very, very simple. I need to only find 2 minimums from 1 to n, and I have already taken the first element, and I have to sum it up and give it. That's it. That is the all gist of the problem. So if I can go tell that sum is nothing but a of 0 initially, and this sum would be required to sum plus the second array, and sum plus the third, and ultimately I'll return the sum like this. But between this, I need to find the minimum, or I would say 2 minimums out of this array, which is starting from I is equal to 1 to I is less than a dot length I plus plus. Okay, 2 minimums out of an array. How I can do it? I can take 2 variables and keep it updating, but I have a better approach, which is priority queue of integer. And this is nothing but, I'm not sorting the array, I'm just taking a queue of only 2 elements. New priority queue. So introducing this would not alter the time complexity, it would still be n O of n. what I'm doing here is I'm dumping the element of a of I, and once I've dumped, and I wanted to remove the element, but this queue is not an ordinary queue. This would be collections dot reverse order, and there you go. This is a reverse order queue. That means my first removing element would be the maximum. So I'll see if queue dot size in any case is greater than 2, then queue dot poll. So likewise, I'll remove the maximum element out of the 3 elements, and ultimately my queue size would be 2 again back. But I have a sum. Wait a second, what I'll do is I'll remove the sum. I'll do a of 0. I have a of 0, which is I have must take first element, and I have 2 minimum elements. So I'll have queue dot poll the second minimum, and queue dot poll the first minimum. So likewise, I can get the sum of these numbers, and that is nothing but that is nothing but sum of the cost. So sample test cases have passed. Let's check with all the rest of the test cases meanwhile. And yeah, it has passed all the test cases. This was a problem related to, I don't know, queues, but it was a very easy problem, by the way. We have solved it in a clean fashion. The time complexity is still being intact with O of n. So that's all about it. For more such content, click the video on your right, and I'll see you in the next one.